Hi all, good morning. Welcome to my next video lecture. Before I am introducing my topic, I wish to say an introduction about the topic. When I was in my first standard, my uncle brought a new TV into my home. It's a black and white CRT TV. When 2016 last, my father brought a new TV. It is a LED TV having thin display with high quality, image quality, high definition. Then I got an opportunity to visit the Lulu Mall at 2018, sorry 17. അവിടെ ലുലു കണക്ട് എന്ന് പറയുന്ന കടയിൽ കയറി ചെല്ലുമ്പോൾ തന്നെ ഷോപ്പിലേക്ക് കയറി ചെല്ലുമ്പോൾ on the left side we can see there is a TV having 1.5 to 2 lakh rupees. ഒരു ടി വിയുടെ വിലയാണ് 1.5 മുതൽ 2 ലാക്ക് വരെ റേറ്റ്. ഞാൻ അവിടുത്തെ സെയിൽസ് എക്സിക്യൂട്ടീവിനോട് ചോദിച്ചു വാട്ട് ദ സ്പെഷ്യാലിറ്റി ഓഫ് ദിസ് ടി വി ആൻഡ് ഹി എക്സ്പ്ലെയിൻ ഓൾ തിങ്സ്. ആൻഡ് അദ്ദേഹം പറഞ്ഞ the main point is that sir, this TV or the display of this TV which is made up by the material OLED, that is organic light emitting diode. So I'm asked that what is the speciality of OLED with as comparing with the LED and LCD. അദ്ദേഹത്തിൻ്റെ നോളജ് വെച്ച് അദ്ദേഹം കുറേ പോയിൻറ്റ്സ് പറഞ്ഞു. അത് കഴിഞ്ഞിട്ട് ദെൻ ഐ എം മൂവിങ് ത്രൂ ദാറ്റ് ഷോപ്പ്. ഞാൻ അവിടെയുള്ള മൊബൈൽസും മറ്റും നോക്കിയപ്പോൾ അവിടെയും അവർ പറഞ്ഞു ചില മൊബൈൽസ് വിച്ച് ദ ഡിസ്പ്ലേസ് ഓഫ് ദിസ് മൊബൈൽ വാസ് മേഡ് ബൈ ദ സെയിം മെറ്റീരിയൽ OLED. Then I came to college. In the syllabus I can see the same thing, that is OLED. Dear students, OLED എന്ന് പറയുന്ന ഈ കൺസെപ്റ്റ് അല്ലെങ്കിൽ ഈ ടോപ്പിക് that is very important because in this scenario or in this age most of the parts of the electronic equipments or the display of most of equipments is made up by the same material OLED. So ഈ OLED എന്ന് പറയുന്ന ടോപ്പിക് that has very importance in your daily lives. So let us study the topic OLED or organic light emitting diode. So let us discuss it in detail. So OLEDs are solid state devices composed of thin films of organic molecule that create light with the application of electricity. We know what you mean by LED. What do you mean by LED? LED means light emitting diode. We know that. So by the application of an electricity, this diode produces a light energy. That's why this is known as light emitting diode. Why this light emitting diode is known as organic light emitting diode? അതിനുള്ള ഉത്തരമാണ് കൊടുത്തിരിക്കുന്നത്. Because this is composed of some thin films of organic molecules. Inside these organic molecules some small parts is made up by the material organic molecule. That's why this special LED is termed as organic light emitting diode. Then next I am explaining the importance. It can provide brighter display on electronic devices and use less power than LEDs and LCD. That is one of the advantages of this. Dear students, let us discuss what are the components or the typical parts of components of an instrument and the working mechanism. This is the typical parts. This is the anode, and this is the known as emissive layer, and this is the light energy produced from this OLED, and this is the whole transport layer, which is also known as conductive layer, and this is anode. Once again, cathode, near to that electron transport layer, then conductive layer or electron transport layer. The last one is anode. We know that cathode is negative and anode is positive. Cathode is negative, anode is positive. Let us discuss each parts in details. So cathode is usually a metallic mirror of Ag or Al with high reflectivity. So what do you mean by cathode is that it is a metallic mirror of Ag or Al. Then anode is transparent indium tin oxide, that is known as ITO. So this is made up by ITO, and this is made up by mirror of Ag and Al. And this MEC layer, which is also known as electron transport layer, which is made up by organic molecules such as polyfluorine, polyparaphenylene, phenylene, etc. And this conductive layer, which is made up by organic molecule like polyaniline. So let us discuss this. This is the cathode which is made up by the mirror of Ag or Al with the high reflectivity. This is electron transport layer, which is made up by polyfluorine or polyparaphenylene, vinylene. This is conductive layer or Hall transport layer made up by polyaniline. And this is the anode, which is made up by indium tin oxide. Let us discuss the working principle. First of all, we know that to produce this light, from this light emitting diode, we need to produce electricity. We have to produce electricity. As the voltage is applied across anode and cathode, cathode receives electrons and anode lose electrons. We know that because cathode means the reduction taking place, anode is oxidation taking place, anode release electrons. These added electrons make an emissive layer having negative charge, because electrons have a negative charge. Simultaneously, by the elimination of electrons cause the production of holes, and that holes produce a positively charged, and that is known as conductive layer. Next, so as we know that the mobility of electrons and holes, we can say that holes are more mobile than electrons. So what will happen? These holes will jump the boundary, and these holes will move to electron transport layer. These holes are migrating, they are conducting. That's why hole transport layer is known as conductive layer. And when these holes meet an electron, this is negative, this is positive, there is a cancellation of charging will be taking place. You know that here the cancellation of charges. So by the cancellation of these charges cause some produce a burst of energy, and that burst of energy is in the photon form. So that photon is emitted from that layer. From which layer? This electron transport layer or the negative layer. So electron is released from electron transport layer. That's why, the light energy is produced from this electron transport layer. That is why this is known as emissive layer. And when the holes meet an electron, positive and negative charge cancel each other, release a brief burst of energy in the form of photon, and this process is known as recombination. Very simple mechanism. First of all, we have to give light potential between anode and cathode. Cathode release accept electrons, and anode lose electrons, because that's the duties. So the added electrons produce a Hall transfer, an electron transport layer, and the other produce a Hall transport layer. As comparing with the mobility of holes and electrons, holes are more mobile than electrons. So the holes will jump the boundary between this ETL and HTL. When these holes meet these electrons, the cancellation of charges taking place by the elimination of a production or the elimination of production or removal of a burst of energy, and this process is known as recombination. And due to this recombination of charges, there is a burst of energy is produced, and that light energy came from this electron transport layer. That's why it is known as emissive layer. So let us discuss what are the advantages. Manufacture of OLED is more economical and more efficient than LCD. And this technology will help us to carrying huge display in our hands. Third point is it is lightweight. Then fourth point is the contrast ratio of OLED is very high even in dark condition. These are the flexible displays. സോ ഈ ഒരൊറ്റ റീസൺ ഉള്ളത് കൊണ്ടാണ് വി ആർ യൂസിങ് ഇറ്റ്സ് ഫോർ റോൾ ടോപ്സ്, ഈ ചുറ്റിക്കൊണ്ടു പോകുന്ന ലാപ്ടോപ്പുകൾ. ദർ ഈസ് നോ ബാക്ക് ലൈറ്റ് ഈസ് പ്രൊഡ്യൂസ്ഡ് ഫ്രം ദിസ് ഡിവൈസ്. ഓഫ് പവർ കൺസപ്ഷൻ ഈസ് also less. Then OLED have much faster response than LCDs. Then what are the applications? It is used in OLED TVs, mobile phones with display, OLED displays, smart watches, roll tops, laptops. It is used in, also used in signals and something like that. Then there are mainly two disadvantages. The biggest thing is that the limited lifetime of organic material. If their organic material destroys, then we have to throw it away. The next thing is that it is the organic materials are displays not waterproof. If water is instantly poured to that, or it's, if it is attacked by something or water is fall on the display, it will destroy. That's the disadvantages. So once again, let us conclude. It's consisting of four parts: anode, cathode, electron transport layer, Hall transport layer. If you apply an voltage between anode and the cathode, this anode release electrons and the cathode accept electrons. When it's the same time this negative layer and the positive layer is formed, holes are more mobile than electrons, so holes will move to the Hall transport layer by jumping the boundary between this ETL and HTL. When these holes will meet with these electrons, there is a burst of energy will be produced due to the process known as recombination. And that electrons, the burst of energy, light energies, came from what, which part? This electron transport layer. That's why this electron transport layer is known as emissive layer. That's about today's lecture. Have a nice day. Please subscribe.